With that in mind, a couple of housekeeping issues. If you would post any questions and or comments that you have in the questions section of the GoToWebinar window. I do not monitor the chat. We'll try to take questions at the very end of the presentation today. We have a lot of material once again to cover. That being said, let's start things off today with a few polls, trying to get a sense of how you're using design tables, how you're dealing with configurations. So first one is, how often do you use design tables? Is it once a day, once a week, once a month, once a year, or I've only used it once? I imagine we're going to have a fairly broad cross-section of users in this case. We got about 71% vote in here. And I'm going to go ahead and close the poll at this point and show you folks the results. As you can see, most of you are using it, but some maybe only a couple times or once a month or so on. So we're going to have a broad, various group within this webinar today. It'll be paced enough for both sides of the table here. So another poll here. Just want to get an idea of what your comfort level is with Excel. You know, are you a casual Excel user? I know some people are very, very good at Excel and would prefer to stay in Excel all day long. Obviously, the reason I ask this is Design Tables uses Microsoft Excel to kind of, publish the table information. Okay, well, I'm glad to see there's nobody saying I can't open it or never used it. Sounds like we got a pretty advanced, 50% or more have more advanced Excel capabilities. So that's nice to see. When I get into some of the Excel functionality, you're probably going to far outweigh what I'm capable of doing. So maybe you could teach me a few things on the Excel level. A little bit about why design tables may be hard for you, because there's a lot involved here. Is it the syntax of the headers in a design table are always confusing? Do you not have time in your design cycle to do design tables? You don't use them enough, so you're just not comfortable. We've already kind of eliminated the whole Excel is hard for me, and most of you are fairly good users. And formatting is confusing. I myself find two things. The formatting is confusing, and the syntax of the headers is a problem. So I put both of those on there. Let me go ahead and show you the results that we have here. You can see that some people just aren't using them enough to be comfortable going in and out doing that. The last poll I have is really related to configurations, but it's related to another tool. Let me go ahead and launch this. The configuration publisher is, and please don't be embarrassed, I can't see who votes here, but there's a tool called the configuration publisher that I'm going to talk a little bit about today. I want to get an idea of who's used it. Okay, we got 22% voted here. Let's see. Well, clearly this is one of those tools that SOLIDWORKS hasn't really put out there in a proper manner. The configuration publisher is actually a tool, which is the first one here. It helps me pick which configuration my users can select for an assembly. We're going to show you how to use the configuration publisher here. Okay, so let's go off to my PowerPoint. And here's our agenda for today. We're going to start out talking about, and the conversation today is really starting out in general. Design tables and configurations go into hand. We create configurations for several different things. First of all, on a part side of things, we do it for families of parts where we can vary dimensions, features, and properties. On the assembly side, we can create assembly families, simplified versions of assemblies as well. When it comes to drawings, we're really just displaying which configurations of the part or assembly we have. there's some things that we need to know ahead of time. First of all, we're going to talk about what is configurable. That has grown every year. In every release, we're able to configure something else within the part and assembly environment that we can add either to a design table or through one of the other methods of creating configurations. That being said, we're going to go over the 3 ways of creating configurations today. We're going to talk about some of the nuances of creating them manually, how to find some of the areas within the interface to set those up. And then we're going to talk about, again, another tool that people just aren't aware of, the Modify Configurations dialog for creating tables that you can use to modify existing configurations. Again, kind of a manual method, but there's some tools built in there that help you to do some modification. And then the big monster, design tables. We're going to talk about syntax and formatting of the tables. We're going to talk about design tables and drawings. 2 topics at the end here. We're going to talk about display states versus configurations. Okay, when do you know to use a display state versus a configuration? And then I'm going to finish things up today with our configuration publisher. Now we only have an hour. I think we're going to have to squeeze some of this in, so let's get right to it. What is configurable? Now we all hate PowerPoint slides that have a ton of information on here. I really just threw that up there to make you aware that there's a lot of things that can be configurable, and this is for a SOLIDWORKS part file. When I say configurable, these are the things can vary between one configuration and another. I can change the center of gravity that I've assigned. I can change individual face colors. I can change sketch relations. Okay, there's a whole bunch of things, whole wizard sizes, materials, and so on, are all configurable within part files. Let's hop real quickly to the assembly side of things. What is configurable there? Well, the stuff we're used to, changing the suppression state of component, changing which configuration is being referenced in an assembly. We can even change dimensions and tolerances of assembly features. Change whole wizard sizes. Okay, the configuration specific properties. Again, this list might seem a little bit long to you. This is all in the help, but you know, there's quite a bit we can vary between configurations. Now, in drawings, as I stated in the beginning, drawing documents we don't configure. A drawing, we just display views that point to the various configurations of the parts and assemblies that we've created. Okay, I will send the PowerPoint out to everybody on the webinar today so you can have these lists that I have here. I'm also going to show you where in the help to get some of this information. Now, it's also important when we're dealing with design tables and configurations to understand what the software is telling us as to how the configurations have been created. If you see this symbol, which is just a traditional yellow block, yellow solid, that means it was created manually using one of the first 2 methods I'm going to show today. If you've used the Excel table, you'll see the Excel icon. Now, if you've created it manually and it has kind of a branch off to the bottom, that means it has either an exploded state or you've created a derived configuration, which again will be part of our discussion today. Excel files with the branch means you use a design table and you have either of those 2 conditions. We will see some of this as I get into the creation. Now let's start with manual creation of configurations. It's just what it says. I have to use the interface specifying properties as I go make changes to create the variations of a design. Okay, so let's jump to SOLIDWORKS for a moment. I have just a very simple part. If I use my rollback here, we can see what was done to create this particular component. We just had a base extrude. It has some dimensions, length, width, height type dimensions. We added a counter bore for socket and cap screw, tapped holes. There's a chamfer on the outside, a cut extrude. If I rotate that around, just a slot cut in it with a fillet. That gets mirrored to the other side. And then there's a chamfer added to finish that slot up. Okay, very simple part. But I need multiple variations of this part, and my first option is to do this manually. Now, manually means I've got to go to my configuration manager. The configuration manager is what contains those symbols I was just talking about. The regular yellow block, meaning this was created manually. Every part that you start with in SOLIDWORKS starts with a configuration called default. Okay, no matter what you create, you're going to have a base configuration for default. Now, how do I create configurations? Well, creating configuration is very simple. We right-click on the configuration manager, and we have the choice to add a configuration. I'm going to add a configuration. Let's say we have an internal part number for this next variation. We're just going to call this 978855 is the number. We can give this a description. Measuring block with new hole wizard holes. Give it some sort of description there. Now this description, if I check this box in the configuration properties, will be used in the bill of materials. Now if I could create this and put this in assembly, and an assembly has a bill of materials, it will use this. Now what is the alternative to this? Well, the alternative is it would be using the custom property. Or if I went to File, Properties, and filled out a custom property called Description, it would use that. This is just a checkbox so that it knows what it's supposed to use in the bill of materials for description. It kind of overrides anything you've done previously. There's a nice little spot in here to put any comments about this particular configuration that you're creating. Now, under the bill of materials options, we can specify what it uses for the part number. So if you have a part number field in the bill of material, am I using the document name, which in this case is part configs? You can see the preview up here of what it's getting. Is it the configuration name, which is going to be my part number that I placed in there? Or do I want to specify a completely different name? I can do that as well. I'm going to have it use the configuration name. Now, it's also important to understand these advanced options. The first advanced option is titled Suppress New Features and Mates. What this means is when a new feature or a new mate is added to a different configuration, a configuration other than 978855, what should it do in this configuration? It says suppress new features and mates. So if there's a new one in another config, it will automatically be suppressed here, and I'm going to show you that. We also can turn on use configuration specific color. So if I wanted this to come out and this one to be yellow, I can go ahead and do that. And you'll see when I exit out, 978855 is now yellow. Now that other option that we were looking at in there specified that it should suppress features if they were added to other configurations. So let's switch configurations. You double click to activate a configuration. Let's just add a new feature here. I'm just going to grab one of my tools, draw some sort of slot profile, and go ahead and extrude it some distance. Now if I switch to the 978855, I would expect it to not exist in that particular configuration. That's because of the property titled Suppress Features and Parts. Okay, that's what that does. Now that part of manually creating configurations is very easy. The part I think is more confusing is if we were to look back at my PowerPoint and go back to the page that lists all of the configurable items for parts. All of these things are found in different spots within the interface. So let's say I wanted to vary the material in these two configurations, the default and the 978.855. What I would have to do is find where I can manually set that up. Again, you would think that it's in material, and it is. So I'll go ahead and edit the material. Maybe I want this one to be made out of some sort of steel alloy. Okay, now there's nothing obvious within this interface, but if you look close enough, you're going to find scattered throughout the interface these config boxes. See this config ... It's kind of hidden down there. If I select that, I'm going to have three options. As I'm making this change, should this change be for this configuration? In other words, the one I have active, all configurations, or do I want to pick from a list? And there's only two now, so I can only pick one or both. In this case, I only want to change it to titanium in the 978.855. So this configuration will work. I go ahead and apply it and close it out. Now you'll notice that it is at the steel alloy. If I were to go back to my default configuration, okay, it should be still set to titanium. That to me is the hardest part about manually doing configurations, is you have to find where in the interface a lot of this stuff is. For instance, if I wanted to vary a tolerance. So let's look where we might go for that. Well, I might pick a dimension. Here I have my tolerances. Let's say I wanted to add a basic tolerance. Okay. And give it some, do a bilateral, and give it some value. Okay. Now, that particular change, I had the option here for configurations. There it is. Do I want to change the tolerance for this, all, or do I want to pick? Notice there's another one down here for changing the name or changing the value of a dimension. Okay, these are scattered throughout the interface. Again, kind of hard to find. Let's try another one that maybe isn't so obvious. The ability to assign mass in the center of gravity. Okay, we'll go into the part. We'll go to our tools, mass properties. Here's my assign mass properties. And again, here's where you assign center of gravity. And look what's built in here. This, all, and specify. So the same kind of options are in here. How about sketch relations? Well, let's edit a sketch. And let's say I'm no longer in one configuration. I didn't want this line to be vertical. Well, what I would have to do is go to my display delete relations. And I can go ahead and use my suppress option, and I can tell the software I'm only suppressing it for this configuration. And that will create the variation for only the 978, in this case it was the default configuration. Now let's go to some of the basic stuff. What if I wanted to remove the chamfer from the default configuration? Here's where we start talking about the whole idea of suppressing and unsuppressing features. Now the thing you have to consider before you suppress something is what other features are going to be removed with it. Now suppressing is not like deleting. Suppressing is just temporarily removing it from the mathematical calculation. But there's one step you have to do. It's called the parent-child relationship. You need to see what children that feature has. And when I say children, it means what other features are required for that feature, or what relies on that feature for its geometry. In this case, what's really nice, the chamfer does not rely on anything. But if I were to want to suppress the base extrude, which is the original feature, look at all the other features that are going to get suppressed automatically along with it. So the first thing you want to do is look at the parent-child, and from there you can use your suppress tools. They're found on your right click on the feature, or they're also found under your edit menu. There's edit suppress and edit unsuppress. And notice each of them has this configuration, all, or specify. Okay, let's go ahead and suppress. Now what if I wanted to vary something dimensionally? I go to the dimension, let's say the thickness here. And let's say I wanted to say this is 45. Now this is one people probably didn't know it kind of changed here. If I come in here, this is 2012. If I come in here and make the pull down menu, here's where I find the option to vary whether or not I'm going to change the 45 in all, this, or specify. So from the perspective of creating various designs, I feel that the only issue with creating them manually, other than the amount of time that it takes, is figuring out where to go to assign a lot of this information. You have to go to the individual features. You have to go to the whole wizard, change the size, and select that button that says configuration in order to make your changes. Okay. I don't think that's probably the most efficient method of creating configurations. Now on to my second option. My second option is a tool called Modify Configurations. It's kind of in between design tables and manual configuration of parameters. Now there's a Modify Configurations dialog box that provides you with a table that allows you to create and modify configurations for commonly configured parameters. Now that's the important part here. SOLIDWORKS says commonly configured parameters. That last list that I showed you are not commonly configured. We don't commonly configure the center of mass or a sketch relation. So here are the list of the things that can be used in the Modify Configurations dialog. And again, I can give you these, or you can find these in the help as well. For parts, we can use the Modify Configurations dialog for features, sketches, dimensions, and material, and that's it. In assemblies, we can do it for components, assembly features, mates, and dimensions of assembly features and mates. So dimensions related to mates or assembly features. Okay. I've got a question already up here, and I'm going to do this while we're here about how to manually configure a whole wizard change. Since we're already right here, since somebody asked it, if I edit the feature, in this case I want to change the whole wizard size. Okay, I can come in here and modify the size value, and here's your configuration box. So I can say, is it for this, all, or specify? Okay, and that's how you can make your variation. So on to the Modify dialog. Let me open up a new part here for a moment. Let's see here. I'm going to actually use this particular part. We'll use this original again. Now, like I said, the Modify dialog only allows you to work with, and let's just reference this, features, sketches, dimensions, and material. So how do we create that table? If I wanted to modify the counter bore, whether it's suppressed or unsuppressed, I can right click on it. You're going to find an option titled Configure Feature. When I select Configure Feature, what it does is it starts to build a table with that feature located in the table, and my option from here is whether or not I can suppress or unsuppress that particular feature. How about the chamfer? Okay, if I double click on it, now that I have the box up, I can double click to add any new features. Now it can also control dimensions as we talked about. So let's bring up my length, width, and height dimensions. Again, double clicking on them in the graphics area will add them to the modify configuration dialog. Okay. Now off to the left you'll notice that it lists only the default configuration because in this case that's all I currently have. I can from here notice this top header where it says counter bore for M12 socket cap screw. I can right click on that header and say rename. I'm just going to call this Hole Wizard or whatever you might want to call it. Rename that okay, you can rename these particular features in the table itself. Now from here, if you want to start creating configurations, there's a actual cell that you select on, and once you have that selected, I should be able to just, and why is it not giving it to me? Well, first thing I'm going to do, and let's just apply this and see. I should be able to start adding configurations here. Okay, it's giving me a little bit of trouble here. Let's start off by actually saving the table. Now the table actually gets stored inside the file, the part file. So I can call this my config table. Okay, there's a little save table view button here. Now let me just say OK to this. Hopefully it will allow me to modify when I get back in. Once you go to the configuration manager, your table is going to be listed right where the design table would be. Okay, if you double click, that will allow you to open that up. Now, okay, this is what I'm doing wrong here for those of you who are watching. To create a configuration, all you got to do is type in the name. Once you type in the name, you click on the cell to the right and it activates the parameters. So let's say for configuration 1, I want to suppress the Hole Wizard, I want to suppress the chamfer. For dimensions, I want 50 by 50 by 250. And I can continue to build my configurations this way. Number 2, we're going to have only the chamfer suppressed. We're going to use some different dimensions. Now when I say apply, I can say OK to this dialog in here, and the configurations are automatically created. There's nothing that pops up like in a design table saying you've created X number of configurations and so on. But I now do have the 3 configurations or the configurations available to me to work with. This is a modify configuration tables. Now here's another thing, and I haven't really gotten too in depth as to how someone might use this on a very large file. But you could come in here and let's say you wanted to work with the parameters on this cut. And you wanted to create a table just for those parameters. Okay, what you can do is go to the dimension, tell it configure dimension, and here are my 2 parameters. When I save the table, I'm going to call this maybe slot configuration. In my slot configuration, I can control each of the 2 configuration names that I have. Currently I have 1, 2, and default. Now it's important to note it allows you to still modify the configurations that currently exist. So I can now change the dimensions. If I wanted these to be even, let's say 10 by 60. And we'll make this 8 by 75. And this one we'll make 12 by 70. Okay, or if I want to create a new configuration, version 3 that has some variation of this, which is, let's say 8 by 50. I've created a completely separate table that I can use just to configure the slots. Now I go ahead and apply that. It has some of them caused rebuild errors, not a big deal. We can look at how that affected that. Didn't save my table. I didn't save the table apparently. But the table will be listed as a multiple in under the table section. So from what I understand, there's no limitation to the number of tables that can exist here. Now, if you want my opinion, and this is purely my opinion, you know how that goes. I'm assuming that SolidWorks was looking at replacing Excel at one point by using this configuration table structure. It clearly isn't there because you can add material, you can add features, suppression state of features, sketches, and dimensions. But you can't add things like center mass and all these other things that we were discussing. So it is very limited, but for a decent subset of folks, I can create a nice interface for being able to modify and add configurations. So this modify configurations dialog box can be very useful to some folks. Let's move on here for a moment. And in assemblies, as I said, components, assembly features, mates, and dimensions of assembly features and mates. Now, the big bear in the room is design tables. Design tables is using an Excel-based table to build multiple configurations by specifying the parameters that you're going to vary. Now, when you do add a design table, you saw the tables folder in the configuration manager. That tables folder will be populated with an icon that looks like this. Now, traditionally, one of the biggest reasons why folks steered away from design tables is the parameter syntax. Getting the headers and the organization of the design table correct so the software can read it in. Hopefully can take some of the wizardry out of this. First of all, the syntax can be either manually typed in a lot of cases or automatically created through the interface. Okay. I brought this image up here because this is directly out of the help file. If you type in summary of design table parameters, let's try that. If I spell correctly here, table parameters. This page here gives you a summary of what you're trying to configure, what the syntax need to be at the header, okay, and what is a legal value for those. It goes parts and assemblies, assemblies only. So what the call out needs to be for each of those. Now it even tells you what happens if you leave that particular item blank. Now let's go into a design table for a moment and just look at the format of it. I'm going to take just a very simple design table here. This one should have a table, I think. Nope, that one's... Let's see. Nope, that one doesn't either. Let's see here. I'll just have to grab this one. Okay. When you're using a table to drive the configurations, as I stated, the icon for the configuration will show in the Excel format. The table will show up under the tables folder. But let's edit the table for a moment and talk a little bit about the formatting of these tables. And we're going to go through the creation of one of them. Now, at some point within the interface, there is a cell, and this is the important part that I'm going to try to show here today. There's a cell, in this case A2, that is left blank, that is really considered the trigger so that the software knows where to start looking for information. Now B2 on over, right next to that empty cell, is where you'll put in the syntax for the parameter you're trying to vary. Okay. Now A3 on down, which is right below that empty cell, is where you type in the configuration name that you're going to use. And the rest of the table is the actual values for those parameters. Now what I want to talk about for a moment here is that blank cell. Because what the software uses to understand where to look for information is the name of that cell. Now if you look off the top here, you can see that now that I'm in the design table, I'm actually in Excel inside of SOLIDWORKS. In the Excel toolbars, you'll notice off to the left there's what we call the name box. Now in the name box, you'll notice that that blank cell has a box titled Family. The software is looking for that family box because it knows from there on over is where I find the parameters, and from there down is where I find the names. So it's important to understand this name box and where it is inside of your table. Now how do I create a name box here? If I go under formulas, there's a define name. And that's what creates this name titled Family. Okay, and the software knows to look outside this. Now, that being said, let's delete this design table for a moment. Okay, what if I wanted to add my own design table to an existing design that maybe I've manually created the configurations? Insert Tables, Design Table. Now I have some choices here. Two of them are automatically going to format the table so that my family cell is where I need it to be. The third option is going to require me to do it. If I start with blank or auto create, the software is going to give me a correctly formatted table. Let me just do a blank table here for a second. Now the options that I have at the bottom control whether or not the table is what we call bidirectional. Do you allow any changes to the model to update parameters inside the design table, or do you have to go to the design table to make your changes? Now the thing on the bottom is a phenomenal set of tools that says if I find new parameters that have been configured or new configurations, do you want me to prompt you to add them to the table? I would always keep these on. Okay, let's keep this blank. Now, what you're seeing is these options that I have set at the bottom coming to life for you. The software sees that there's already several configurations manually created, so it's asking you to select which ones I want to add to my table. Let's say I just want to add a couple of them. And then it sees which parameters have been configured between those variations. And I can select a few of those. These are the syntax that we were talking about. And I'll say OK to this, and it will fill out part of my table for me. But what I really want to get at here is this. If I go to that blank cell, notice what's there. The family name box. This again is the trigger so it knows where to look for that information. Now why am I focusing a lot on this and maybe not so much on the syntax as of yet? Well, let's take a look at some of the things that I might be able to do if I understand that idea that I can create my own table externally. Here I just have a very simple block with some dimensions to it. Now the first thing I did with this is I wanted to make the dimensions a little more logical. So when I put them in my table, they don't say D1, D2, D3. Now we used to have a nice little option under our tools options that said show dimension names. Most of you are old-time users knew it was right here under general. Well, guess what? It's not there anymore. It hasn't been for a few releases. In the window where I have my hide show items, my view toolbar, if I pull that down, you're going to see a little symbol, it looks like a D1, where I can turn on and off dimension names. There's my length, width, and thickness. Now I've already applied the dimension names in this case. How did I do that? If I select a dimension, you see there's a section in here for primary value. As long as you just change this beginning part, it will still keep the locator, but this beginning part can be modified to give it a logical name. Now let's go outside of SOLIDWORKS for a moment because I want to talk about the design table that I created outside of SOLIDWORKS. Now what is the problem with doing it this way? The problem with doing it outside of SOLIDWORKS is that you need to specify to SOLIDWORKS where it's going to start reading for data. And how do we do that? By creating a cell that has the name titled family. And I did this just through formulas. I said define a name. I typed in the name family and I defined it to whatever cell I want it to be. Now it doesn't even have to be in the A row. It could be over here in R. But it knows to look down and over from there for the parameters and information. Now what is this going to allow you to do? This is going to allow you some flexibility. By me assigning that to cell A6, I now have this whole upper region to do what I want, create a header, put my logo, do other things to it. More Excel-based functionality in formatting. SOLIDWORKS really only cares about the family cell and the parameters to the other side of it. So just so you can see this live, I can now come in here and insert my design table. I'm going to create it from File and select my design table. Okay, once I accept it, it brings in, it will tell me the number of configuration I've created, and it will physically create those. Notice that wasn't formatted the same as the others, but the end result is the same because my family cell existed in the proper spot and it was able to read the information. Now let's go a little bit further with design tables here because getting the syntax right is important. I'm going to actually go back to my default and delete the other 4. Now deleting configurations, they must not be active. So default is currently active, so I'm able to delete the others. Now let's say I wanted to create a design table from scratch. Insert my table, design table. I want to create a blank table to start with. Okay, it automatically creates my family section, and it comes up with a series of parameters that I can use. Now let's say I didn't use any of those. Okay, here's where I'd have to use the interface in SOLIDWORKS to start filling out this information. If I double-click a feature, that's going to fill out the syntax for suppressing or unsuppressing a feature. If I double-click a dimension, it's going to fill out the syntax for modifying that dimension in configurations. I'm going to do that a couple times. Now let's say I wanted to create a configuration where the description property varies. Well, here's where sometimes you're going to want to just exit the table and come back into it. And I think this is a better approach to this. I'm going to vary a couple things here. If I go to my file properties for a moment, which is where we fill out our custom properties. There's another tab in here called the configuration specific. Okay. In here, I can fill out things like description, and I can say this is my default. Now, all I've done is apply a specific configuration value to the only configuration I have currently, which is default. But what happens when I start doing those things manually, and I'm going to do it for material here, I'm going to go ahead and edit my material. I'm going to say I want 1020 for this configuration, apply it, and close. By modifying those parameters, I now have triggered the software so that when I go in and edit the table, it sees those things, and mine didn't come up that way. It may have shown the first time. Huh. Well, here's description. It didn't get material for me. But it will see that as a changed parameter, like the description, and now I can add that to the table just by selecting that in the bottom. Now, if I want to vary that information in this configuration name, I can just type in whatever that value is. So sometimes it's easier to head out of the table, configure it, and then use that dialog when you enter back in to fill out the headers. And I'll be blatantly honest, sometimes it's easy, just as easy to go into the help, figure out what it is you're trying to configure, like hole wizard size. Okay, I don't think we have any hole wizard in this particular part, but typing that into the header and then typing in what your parameter changes are from there. Okay. Again, the hard part is getting the syntax, which I've given you a resource here of getting that syntax in there correctly. And that will allow you to better set up your tables. Now let's take a look at some tables that maybe are a little more complete here. I have an assembly table. We haven't really discussed a whole lot about assemblies, but assembly design tables allow me to configure which component is being referenced, assembly feature dimensions. So let's edit this particular table. Again, the syntax is going to be the same. I still have my default cell here, the family name, and then I have my headers calling out which configuration of each component is being listed here. Now here's the custom property description, $PRP description, which assigns a unique description to each variation of this particular design. Okay, what this design table does is for each variation it's calling out which version of the tail cap, which version of the head cap, tube, tie rod, piston rod, O-ring are being used, and is there a section cut, and is there a rod clevis. Okay, if we take a look at this, I can kind of flip through and you can see the multiple variations created. Okay, I guess my biggest suggestion with design tables is to make yourself familiar with that help section on what the syntax is, and the whole family location, the family name icon will allow you to configure that table a little bit better. Now the last thing I wanted to, well, actually there's a few more things in here. Let's see here. Just a general comment about display states versus configurations. How do you know when to use display states versus using a configuration? They're often confused. Well, display states should be used when all the components in each configuration are the same. Okay, all we're really modifying is the visual properties of those components. Are you going to hide some of the components? Are you going to display them in a different color? Are you going to show them in various stages of assembly? In other words, hidden, maybe transparency. But all the components are the same. Then you would use display states. For configurations, as we've been talking about, this is when you're changing the various sizes, simplifying parts, components that use different dimensional parameters or material parameters. Those are the reasons why you would use configurations. Now, something that I asked about in the beginning was just something called the configuration publisher. Now, 10% of you got this correct. It's used to aid a user in picking which configuration can be added to an assembly. Now, when it's been created, you'll see a property manager table listed in the configuration manager. So let's go and take a look at that. I have a completed version done, and then we'll create one on our own here. Now, for this caster, if I go to my configuration manager, you can see there is a property manager listed there. If I right-click and edit the feature, this brings up the design table that it was used to configure the assembly and an interface that was created to help a user make selections. Now I'm going to show you how this works, but I'm going to go to the preview. Now in the preview you actually see what it will look like when you drag and drop this assembly into another assembly. It's going to ask you which diameter wheel do you need, 2.5, 3, what style, there's different styles of this caster, what mounting type, we're going to do square stem. By asking these questions, all it's really doing is picking the proper configuration for selection into the assembly. Now, this is to be used when you have large numbers of configurations, and it makes it hard for a user to pick and to fish through all the configurations to decide what size or style they need. If I hit Update Model, it actually updates and shows me what that configuration looks like. This is the 2.5-E-SS. Now let's create one of those. Actually, let's put this in assembly so I can show you where that works. If I say make assembly from this assembly, and I decide to insert the roller caster, notice off to the left what comes up. Okay, it's asking me if I want to specify the parameters for that caster. Yeah, you know, I need a 4-inch diameter. Okay, I need a boltable plate. It knows which configurations I have available to me, and now I can easily insert the configuration that I need. The configuration publisher is that interface that we use to create for the end user. Okay, so let's get through some of this here, close some things down. Okay, now my example here is very similar. I have a 1/2-inch cylinder. Now to start creating my configuration publisher, I just go to my configuration manager and launch the configuration publisher. Okay, now there must be a design table already in place on the assembly because the configuration publisher is only helping you pick which configurations are already created, whether you did it manually, did it through a design table. Now, for creation of this interface, we just drag and drop one of my 3 options: lists, numbers, or checkboxes. I'm going to start out with a list that allows me to select the mounting type. Now the mounting type is tied to what variable on the design table? Obviously mounting type. Okay. Now for the list, what I want to show the user, I have 3 different mounting types, and I'm going to go ahead and place those in there and apply it. Now I have another list in here which comes after the mounting type, which is the cylinder type. Now the cylinder type, again, is going to control the cylinder type property. Okay, is it a list or a range from a list? Now the parent is based upon mounting type. In other words, if somebody picks a certain mounting type, I want to have particular options. Now what we're doing here is if you pick stud, I want it to show an option for single acting, double acting, or reverse. If I pick front block, I don't want it to have the selection for reverse acting, so I'm going to go ahead and delete that out. If I pick universal, I'm going to have it allow for all three, and we'll apply that. My last list we'll place on here is for the rod type. So we'll type in the name of the box as our rod type. We'll select the property for rod type. The parent in this case is the cylinder type that I just selected. So once they've selected mounting type, it gives them the options for the cylinders that go with it. If they make the selection of the cylinder, that's what will give them the options for what rod types are available. Okay, I'm going to grab that data here and paste it in. Now, for single acting, we have two different rod types. Double acting, we have two different rod types. Everything else has the single rod type option. We'll go ahead and apply that. Now, there isn't a tab in here to allow you to preview what you've done. So now I can come in here and see what I'm getting. For my mounting type, let's say we wanted front block. Front block should only have two options, single or double acting. Okay, if I want a double-ended rod, I tell it to update the model, and you'll see that configuration live. Okay, if I want to make single acting, rotating rod, I tell it to update the model, and you'll see that change live. Okay, so you're just building this interface to help you to pick which configurations. I want to be clear that it's not modifying parameters. All it's doing is changing configurations. Now let's go back to our edit for a moment. We want to add a checkbox in here. That checkbox is for a mounting bracket. Now, this is going to suppress or unsuppress the mounting bracket. If it's checked, it's unsuppressed. Now, I only want that checkbox to show up if a certain mounting type is available. In other words, I don't want it to show up if front block and universal are selected for mounting type. Now, let's take a look at that. If I select stud, you can see it's an option. If I select front block, the checkbox goes away. Again, you're creating almost this foolproof interface that the user can have. Now, as far as numbers go, I can drag a number in here. Maybe this number is stroke for the cylinder. And I can have it vary the stroke parameter. I can tell it we're going from 1 to 4, and it has to be in quarter-inch increments. If I look at my preview, here's my box for that. If I put 4.25, software tells you you're out of range. So it requires you to put in parameters that make sense, and the models will update based upon those parameters. Okay. So that is the configuration publisher. I think it's fantastic when you have when you kind of get lost in the number of configurations that are available to you. They can kind of keep things a little bit cleaner. Now, to finish out today, I want to talk about two other special types of configurations that, to be blatantly honest, I didn't even know existed until I went picking through some of this stuff. There are times when you want to open up an assembly with all of the components unsuppressed including ones that were suppressed for a particular configuration. And there are sometimes when you want to open up assemblies with a configuration that just shows the assembly tree. Now you can make those automatically through the File Open dialog. Well, let's go in here and do a file open on, we'll just do this on my Rollercaster here. Under configurations, I can choose to open up any of them that exist, or there's an option in here for advanced. If I select advanced and say open, I'm presented with another dialog. Two of the options creates new configurations for me. Do I want to create a new configuration showing all referenced models, meaning any model inside the assembly, they're all showing? And the reason why that might be important, you have some configurations where parts are hidden or suppressed. This one will be all showing. Or if it's a very, very large assembly and you just want to look at the tree structure, tell it to create a configuration showing the assembly structure only. And I'm going to just call this simple and say OK. Now the assembly is going to come in blank, but you're going to see the assembly structure. Okay, this is what we had for structure on the assembly. If I look at the configuration manager, you can see that it created a simple version configuration so that I can only view the tree structure. And again, if I do it the other way, it's going to show all the components if they weren't shown. Okay, I think that's what I had for today. I want to thank everyone for coming. If there's any questions, comments, you want to get in a little deeper, we want to do something one-on-one, let me know. Email is kevin@caddimensions.com. In 2 weeks, we'll start to get